Hey everybody, welcome back to another map of the day. And the map we're going to be looking at today is called Hippo Regius. So this is not the most unique map ever in terms of special mechanics. Basically, what we see is what we get. But the creation of this involves some techniques that I haven't really talked very much about, so I think it would be a good opportunity to go over this and see what's what. So we can take a look at what we have here on the map. So we can see that the wood in this map is fairly sparse and pretty concentrated in the corners over here. Players have a bit of gold and stone by their bases, but all the extra gold is in these pits here, which is surrounded by this rock terrain. So if we were to try to build here, we can see that the slopes of this pit are not buildable, but inside we have space for a mining camp. So map control is important, and it's not very easy to defend these pits since it's very hard to wall around here. So let's get started in the process of making this map. So when we think about how to make these pits, we have to realize that in order to get these pits to spawn at a different elevation than the rest of the map, it means that all of this terrain has to be in place before the elevation section, which means each of these individual pits has to be created as a land statement as opposed to trying to space it out with something like terrains. So let us go to a test script and we'll go into a land generation section. So if we were to say create land, just a generic create land statement with a terrain type of, let's say DLC desert gravel. And we'll also say number of tiles 0. So we can go into a test script and we can see that when we generate our map, this land will appear with the default base size of 3, and we can keep on generating, and it will, we can see it will spawn in very random places because we haven't really given it any constraints. Now, one thing to realize about randomly creating lands in places is that if we keep repeating this, first notice that there is nothing preventing lands from touching each other on their own. And then if we just keep on repeating this, another thing to notice is that lands that we just generically allow to spawn in the map will tend to avoid spawning in the corners of the specified borders. So we have specified no borders on our map, so in theory we would expect these lands to be able to generate anywhere on this map, but they will always tend to avoid the corners. Now, to address this, there's a couple things we could do. For example, if we needed lands to spawn in these areas, in these corners over here, we could try to adjust the borders to allow lands to spawn in this area. So if I were to take a land similar to this, but I add borders to it, so I say top border is 67, and also the right border is also 67. So we have the top border here, right border here. So you would expect to allow one land to generate in this corner over here. And we can see that that's essentially what happens. But also notice is that if we were to apply that to all these lands above here, so that we want all of these to spawn in the corner over there, we can see that in this little corner we specify, if we were to draw a box around here, it will avoid the corners of this box also. So in most situations, these little patches that are left over aren't really that noticeable in terms of getting lands to evenly distribute on a map. But in our case, we really aren't going to worry about that too much, because instead of trying to fill these corners with those gravel pits that would contain the gold and stone, what we saw earlier is that we just covered these corners with wood, so we don't really care that the neutral lands that we randomly create will be avoiding that. So up at the top here, we can say constant palm grass, which is basically a forest terrain that has palm trees but has an underbrush terrain of grass instead of desert, which is normally how palm desert spawns. And so let's revert this back to the way it was, where we don't have the borders anymore. Now, I have a base elevation applied to these lands in the corners because the gravel pits are supposed to be at a lower elevation, which means the rest of the map has to be at a higher base elevation. And since I have that, I need to put an elevations section in. And we see in this case the fact that our neutral lands are going to be avoiding the corners is pretty beneficial in this case, because we really don't want them to be spawning in the corners anyway. So if we look at our map now, we can notice that these neutral lands that we allow to randomly generate are rather close to each other, far closer than would be preferable to have in a normal game. So there is a way to space these out a bit more evenly, and that's with the attribute min placement distance. So let's comment out all of these lands but one for now. And we will add to this land the attribute min placement distance of 20. So what this is supposed to do, this attribute, it's supposed to keep this land from spawning within 20 tiles of another land's origin. So if I were to apply that to, let's say, 2 lands, we would expect that these lands, because of this attribute, would not spawn within 20 tiles of each other. So if I keep on generating, we can see that for that this distance is going to be respected. Now, it's not as easy to see when we only have 2, but if we start to add more lands with that min placement distance, this should be a bit more noticeable that none of the lands are able to touch each other, because we have that attribute specifying that all these lands should be at least 20 tiles away from another land origin. Now, if we keep doing this, if we keep repeating these statements over and over again, there's going to come a point eventually where we're going to run out of space in the map, so that we can no longer satisfy that min placement distance and keep the next land 20 tiles away from all other land origins. So if we do that, we can see that most of these lands are respecting that min placement distance. It's just that this little area in the middle has this land here and this land here, which are touching. And that goes to the fact that when this min placement distance attribute cannot be satisfied, the land in question will automatically go right in the middle of the map. So we can keep generating, we can consistently see a land in the middle of the map, in the exact middle, which would indicate that there is at least one land that could not find a place to go because it could not satisfy the min placement distance, because there are too many lands to avoid in this case. Now, the awkwardness of having these two lands spawn a bit closer together than we would like is something we're going to address later. But for now, we just want to make sure that we have enough land statements that can cover the map in all map sizes. So it doesn't really matter that we have potentially more lands than we would need in a given situation, because any lands that couldn't find a place will just end up in the middle here, and the ones that are able to find a space will kind of distribute themselves evenly, as we're already seeing. So this over here just adjusts the number of tiles, adds some borders in so these pits aren't going to be necessarily touching the edge of the map. They'll stay a small distance away. But the next order of business is, now that we have the appropriate size for all of these gravel pits, we need to next figure out what's the best way to handle the elevation on our map, so that these pits end up at the lower elevation. So if we were to, well, let's see, these neutral lands, which are the trees, are generating as elevation 2. So for a first stab, we will try to just do a generic create elevation 2. So we'll just have a generic create elevation statement, which is trying to generate elevation 2 on grass. And importantly, have to specify the base terrain of the map to be grass. Okay, so this does a decent job of getting the rest of the map up to elevation 2. But let's also say that in addition to the elevation that brings the rest of the map up to this elevation 2, we also wanted to create other elevation to put some hills on the map to give it a little extra terrain variety. So let's take a copy of this. And so instead of creating elevation 2, we'll create elevation 4. And then instead of 10,000 tiles, which is enough to cover the entire map, we will say only 1,000 tiles, which should not be enough to cover the entire map. See, when we do this, we can see that for the most part, the elevation is balanced everywhere, except for this side here. So there are some situations in which generating elevation on top of land which is already elevated by a create elevation statement can lead to some issues. It's not super predictable what's going to happen, but generally speaking, if it's possible to use a base elevation on a land as opposed to creating two separate elevation statements to elevate the same terrain, it's usually preferable to do that instead. So let's get rid of this for now. Now, we haven't added any player lands to the game at this point, so let's try and do that. So we'll say create player lands. So the terrain type is going to be the terrain type of the rest of the map, which is grass. Land percent is going to be 100. And then base elevation is going to be 2. So in this situation, we would rely on the player lands to get us up to that base elevation of 2, so that we would need only one create elevation statement on this grass instead of trying to do it with 2 elevation commands. So base elevation 2, we'll say can be 30. And then we'll also pay attention to the zone. So notice that these gravel pits are supposed to have zone 1, and other zone avoidance distance of 2. So if we were to say that the player lands will have zone 2 and other zone avoidance distance of 2, then the gravel pits should stay away. Let's get rid of this. For a second. So this is able to get the map up to elevation 2, which is the intention. And then we'll notice when we bring back this create elevation 4, that it's going to be far more balanced when we repeat these generations. Of course, it will avoid spawning near the player lands because elevation statements do that automatically. But in terms of the rest of the map, the elevation is much more balanced compared to if we were to use 2 create elevation commands instead of just this one. Now, here we've arrived at a generation where it looks like there's a land here that was overlapping some of the excess lands that happened to have to generate in the middle of the map because there wasn't enough space. We can see that this pit is quite a bit bigger than all of the other pits over here. So we don't necessarily have to use the player lands per se to get the map up to the base elevation of 2. If we were to reduce this land percent down to 0, we could potentially create another land in the middle of the map here. Importantly, we'll specify the land position to be 50-50. And then the terrain type can be grass. This can also have zone 2 and other zone avoidance distance of 2. So the fact that we did not specify a base size for this land means it will default to 3. And whenever 2 lands are occupying the same location, in this case, this land position 50-50 is going to be the location where all the excess lands are going to generate that couldn't find a place to generate randomly because it couldn't satisfy this min placement distance. So when all of those lands have the same position, the one that's going to show up is the one with the bigger base size. Also, I'm forgetting that this is supposed to be base elevation 2, but basically what I was saying was that since these gravel pits that would spawn in the middle of the map have base size of 0, and this grassland in the middle has a base size of 3, this is the one that's going to show up. And when we do that, we can see that we are able to mask the fact that we have a bunch of excess lands in the middle of the map here that couldn't find a place to go because they couldn't satisfy min placement distance. Now, this prevents us from being able to have a pit in the middle of the map because we have that grassland in there, but that's a sacrifice I'm willing to make to get the map looking a bit more seamless and making sure that all of these pits over here are approximately the same size throughout the map. So the next order of business is, I mentioned at the beginning that the forest on the map was not going to be 100% dense, and the forest we are using is basically palm trees on grass, which has 100% density. So this next step is to figure out a way to make this forest less dense than it usually is. Now, in the past, I've gone through examples of trying to use a different forest as a base. So, for example, if we were to use acacia forest as a base, which is about 50% dense, not 100%, we could start off with this as the base terrain and upgrade these trees to palm trees and achieve about 50% density there. But in our case, the first issue is that this savanna terrain underneath the acacia forest isn't necessarily what I want underneath this palm forest over here. I like it being the way it is, grass. And secondly, there is a way to have the density of the forest be even more customizable than just relying on whatever density acacia forest is. So let's go through that right now. So in this demonstration, what I'm going to do, the very top, first I'll get the player setup section in. So what I'm going to do first is I'm going to say effect amount set attribute palm tree etr terrain ID 3. Now terrain ID 3 is normally a terrain ID that is restricted from being placed on land terrains. So when I do that, let's see what happens. So the minimap looks the same, but we can see that there are no trees anymore, even though the forest terrain looks like it still appeared on the minimap. So what's nice about this is we basically have a blank forest terrain over here. So if we were to take some trees, we'll put a tree here, which is on the forest terrain, and a tree here, which is not on the forest terrain. The benefit of having a blank forest terrain, so to speak, is that regardless of whether we place a tree as an object or as a terrain, the ability to remove it with a building foundation is simply based on whether or not that tree is on top of a forest terrain. So we can see that this tree that was not on a forest terrain can be removed with the, but this tree, which is technically on a forest terrain, cannot be removed with a building foundation. So it's in this way where we can basically customize whatever density we want for forest by creating objects at whatever interval we choose. So let's go back to the map script and we'll go into an objects generation section. So if I wanted to bring back some trees, what we can try is create object oak tree. Number of objects is 500. Set scaling to map size, and we'll say terrain to place on is palm grass. So we'll go back to the test map. So when we create these trees back in the objects section, we can do this with confidence that these will be considered forest trees, meaning we won't be able to remove them with building foundations. Now, creating forests based on objects doesn't necessarily clump the same way as normal terrains do. It gets pretty close, but you can see that objects are fairly dense along this edge, but fairly sparse along this edge over here, which can be annoying in some cases. So you can play around with object attributes to try and adjust the spacing of these trees. Or what we can do instead is that we can try something else, is that we can try something in the terrain generation section, which is like create terrain base terrain palm grass and %5 number of clumps can be a lot. We say terrain mask is going to be 1. So instead of creating just a small number of trees, we'll create pretty much as many trees as we can. We'll still say terrain to place on palm grass, but we'll also say layer to place on is normal grass. So it's in this way where we can kind of get objects to spawn with a very similar distribution as a terrain would spawn, because we're essentially using this terrain to dictate where those trees would go. Now, I used oak tree as an example here because we can go back to trying palm trees, but as we saw up here, we shouldn't be able to place palm trees on a normal ground terrain because of this terrain ID that we changed. But this isn't really a big deal for us. We can get around this with a placeholder. So if instead of generating the tree, we just say generate terrain blocker and have the tree as the second object. See, now we have essentially the exact same forest, except we are able to control the density of it however we like. So that's kind of a neat thing to be aware of, is how to customize the density of a forest to be however dense you would like it. Alright, so at this point I've updated the map to basically what it's supposed to be in terms of the cosmetics. So just a couple things to keep in mind is that when this is a two-player game, I have it set to direct placement instead of random placement. Ironically, even though neutral lands tend to avoid the corners, player lands don't have that kind of phenomenon going on. So the fact that this is direct placement is just intended to keep the players from spawning too close to the corners and to keep the players a bit more equidistant to each corner. It's not a huge deal for a map such as this, but it's just something to note. But what I wanted to focus on next is getting the golden stone to spawn in these pits over here. Now, this should seem pretty straightforward, because if we go into those lands which comprise the pits, these have a land ID 1. So if we were to go into the object section, we were to say create object gold, we were to say place on specific land ID 1. So we should know that so when we generate, we should expect one gold pile to appear in each of these pits over here. We would not want them, we would not expect them to spawn outside of the pit, because this is surrounded by rock, and we should not be able to place a gold pile outside of that zone, because rock is restricted for placing gold piles. But when we do that, we can notice that first of all, when we look at each of the individual pits, we can see that there looks like there is indeed a gold pile in every pit. But also notice that around the map, there's a bunch of these gold piles which should not have been able to spawn. And what's happening here is that even though we cannot see the terrain of all these lands that were generated, it doesn't mean that these lands don't exist. So essentially what it's doing is, for every land that could not find a place that ended up in the middle of the map, that is also comprising land ID 1. And so that's what's causing all of these gold piles to show up in the middle of the map. Since their land position is right in the middle here, basically their range of placement is everywhere except these pits, because this is the only area that's a restricted terrain. Now, this is just one thing to keep in mind, but it's not very difficult to get around that kind of phenomenon. we just simply say terrain to place on is DLC desert gravel. So basically all of the lands which are supposed to have the gold in the pit is able to spawn in here, and all of the land ID ones that were in the middle of the map over here, those are not able to spawn any gold pile because they could not find a path towards DLC desert gravel that was not separated by a restricted terrain, which is rock. Okay, so again, I have updated the map with what the objects are supposed to be, except for one important step. And that step has to do with the fact that for each of these pits that contain the extra gold and stone, I want to ensure that there is enough space to place a mining camp. And due to how the randomness of these lands generate, and the randomness of how the golds and stones generate, there are a lot of cases, most cases, in which there is space for a mining camp. But there are also some cases in which there is no space. So what I want to do is I want to make sure that for all of these pits that there is space for a mining camp. But at the same time, I like the way these pits are sized, so I don't want to change the size of them to make them bigger, to make sure we can fit a mining camp in there. So what I'm going to do is I'm going to use a different object. So that object is 1776. Now, this is called blocker, and essentially it's the exact same thing as terrain blocker 1613. The only difference being is that terrain blockers 1613 has 0 hit points, so it goes away at the start of the game, whereas this one 1776 has 1 HP, so it will remain in the game and keep blocking things throughout the game. So what I want to do is that prior to placing any of the gold mines and stone mines, I want to create a 2x2 space, which is just going to be empty space to ensure that there's going to be space for a mining camp. And I'm going to use this object to do it. Normally I would use 1613 because that already has 0 hit points, so it will go away as soon as the game starts. But I'm already using this as a placeholder for the trees, so I got to use something else. So what I'm going to do is I'm going to say a couple of effects. So first, I want to set the hit points to 0. And then I want to set the size of it to be the exact same size as a mining camp. So this would be ATTR radius 1 and ATTR radius 2. I want to set these both to the value of 1. And then another thing I'll do is I will set the terrain ID of the blocker to be 8. See, these blockers normally have a terrain ID of 0, meaning that they can be placed anywhere. So if I were to do a similar thing and place this on specific land ID 1, there would be nothing preventing, or no restricted terrain preventing it from placing it for all of these neutral lands that couldn't find a place. So we scroll down here to see, this is just before we are creating the golds and the stones, so that I'll create blocker, place on specific land ID 1, and find closest, and terrain to place on DLC desert gravel. And to indicate where that is, I will say second object is mining camp rubble. So we should be able to look around and see that there should always be a 2x2 empty space to create a mining camp, and that space would be indicated by the mining camp rubble that's underneath that blocker. Now, this isn't going to show up in the editor because the effect of removing this blocker isn't going to come into account until we actually start the game and the hit points are set to 0. But we can check now, as we checked at the beginning of the video, that once that terrain blocker is able to go away, it's going to leave that 2x2 area remaining, so we always have space for a mining camp. Now, this mining camp rubble is actually pretty helpful in determining exactly where in this pit the mining camp should be able to spawn. Because of the terrain blending, it's not always obvious, so I would like this rubble to stay around for longer than it normally would. Usually, building rubble lasts for 60 seconds, but that's something we can change if we wanted. So I can say effect amount set attribute of the mining camp rubble, attr storage value. I'll set it to a really big number, 30,000, so it will last for 30,000 seconds instead of 60 seconds, so it'll stick around in the game for several hours. Now, the last thing about this map that I wanted to talk about has to do with the fact that this map was created with the intention of having a 9-villager start, which is a style that's becoming increasingly more popular. And one of the features that's supposed to be part of the 9-villager start is that there's supposed to be a herdable underneath the TC that dies as soon as the game starts and also has 30 less food on it than it's normally supposed to have. So the way it's typically done to get a herdable with a different amount of food and a different amount of hit points than the rest of the herdables on the map is by using a different object. For example, most of the herdables are sheep here, and the one that's supposed to be different is a turkey. But even though we would use a different object in order to have different properties, it doesn't necessarily have to look like a turkey. We could change that by using an upgrade unit effect if we wanted. So if I were to go back here and I were to say effect amount upgrade unit, I'll upgrade a turkey into a sheep. So I can restart the game. And now what used to look like a turkey is still technically a turkey in terms of unit ID, but it looks like a sheep now. And if I were to modify the attributes of turkey, so I set the turkey's hit points to 0 and the turkey's storage value to 70 instead of 100. We can see that the sheep died at the beginning of the game and started with 70 food. Now, I want to take a second to explain what is happening here. So basically what we started with was a turkey, and we upgraded it to a sheep. So we took all the properties of a sheep and copied it from index 594 to index 833. So even though this has the same index and the same in-game name, it looks like a sheep, has the hit points of a sheep, and has the storage value of a sheep. So when we do these modifications of these attributes, we are modifying turkey index 833, so 0 and 70, which is why it works that way. Now, the order in which we upgrade units actually matters quite a bit. See, what we're doing is we're upgrading the turkey into a sheep first and then setting the attributes second. Let's say we did it a different way and we upgraded last. See, in this case, it didn't do what we wanted it to do, because what we just did in that case was we first took the turkey, we set its hit points to 0, its storage value to 70, but then we did the upgrade. So we just basically then took all the attributes of a sheep, put it into turkey, basically overriding all the changes we did. If we were to do it this way by reserving the upgrade unit until after we changed the attributes, we would have to modify the attributes of sheep instead of turkey. But when we do that, we affect not only the one that's underneath the TC, we also affect all the other sheeps on the map. Because basically what we did in that case is we took a sheep, we set its hit points to 0, its storage value to 70, and then we copied all these attributes into the index of a turkey. So regardless of whether we place sheep or we place turkey, they will all have 0 hit points and 70 food on them. But if we were to take this a step further and say after we upgrade turkey to a sheep, we then set the attributes back. So we said hit points is now 7 and the storage value is 100. See, now we're back to having the correct setup, because what we did there is that we just started from this point here where both of these unit indexes are sheeps with the same attributes, but then we changed sheep back to having 7 hit points and 100 storage value. So 100, so 7 and 100 to get the sheep back to what it's supposed to be. Now, I don't know if that kind of a technique is common knowledge, but the applications for something like this, having a unit look just like another unit aside from a few key properties, is not something that's just limited to sheeps and turkeys. Basically, this can apply to any object as long as it's not an object a player would create in the game. So if I were to give an example, let's just say that this unit 1776 didn't exist, but I really wanted to use something that's exactly like a terrain blocker, just with a different radius. So it takes up a 2x2 area instead of a 1x1. What I can do in that case is I can look at the Advanced Genie editor. I can see that terrain blocker is class 14. So I could basically choose any of the objects here which are of the same class that would not appear normally in the game, and I could upgrade that into a terrain blocker, and then whatever properties I want to change, I can just change those properties. So if I were to use, let's say, 1567, I could just upgrade 1567 into a terrain blocker, and if I just wanted to change the radius, I could just change the radius of object 1567, and it would work the exact same way. A terrain blocker would still be a terrain blocker, and we could use it as a 1x1 object, but then object 1567 would be exactly the same as a terrain blocker, except for the radius, which we modified. So that may have been me going off on a bit of a tangent there, but that's basically all the things I wanted to cover on this map. So hopefully you guys have learned something, and thanks everybody for watching.